All right, in Orgo 1, I generally focus on Grignard and then oxidation and reduction of alcohols. So we learned some oxidizing and reducing agents. And so this is a set of reactions that really is just going to ask you to think about, well, is it being oxidized or reduced? And so there's a couple of things to remember, that there are some oxidizing agents that are stronger and weaker, and there's also some reducing agents that are stronger and weaker. The strongest reducing agent is lithium aluminum hydride. The strongest oxidizing agent that we typically use is sodium dichromic acid. And the two weaker versions, the weaker oxidant is pyridinium chlorochromate. That's PCC for short. It will not oxidize a terminal alcohol all the way to a carboxylic acid, but sodium dichromate will. The weaker reducing agent is sodium borohydride. It will reduce a carbonyl, but it won't reduce a carboxylic acid, and it won't reduce an ester. Lithium aluminum hydride, however, will reduce everything, and that's just kind of what we need to remember. Okay, so here we are. We have a secondary alcohol. It's being oxidized. That's the other thing you want to look at. You want to say, okay, I'm increasing the number of bonds to oxygen, so I'm oxidizing. So it's not primary, so I don't actually need to worry about whether or not it's weaker or stronger. So I can use either of my reducing agents. Let's go ahead and just say I'm going to use sodium dichromate, H2SO4 with some sulfuric acid and some water. PCC and pyridine with CH2Cl2 would have been fine as well. But let's take a look at this one. I do have a primary alcohol, and I am oxidizing it, but I'm only oxidizing it to an aldehyde. That means that PCC and pyridine is the only correct answer here. If I were to use sodium dichromate, this would have oxidized all the way to a carboxylic acid, and that's not what happened. That's what happened in the next reaction. So the only correct answer for this reaction is the sodium dichromate set of reagents, because if I use PCC, I won't get the carboxylic acid, I'll only get the aldehyde. Okay, well, what's happening here? This is the reverse of the second reaction. I am reducing the aldehyde to a primary alcohol, and I don't need to worry about my reducing agents. Both sodium borohydride would work, but so would lithium aluminum hydride, followed by water. Both of those things would work. Now, let's take a look at the last reaction. This is an ester, and the ester is reduced to 2 alcohols. But look what else has happened. I'm reducing a carbonyl group to an alcohol. If I were to use sodium borohydride, I would get a reduction happening at this location, but I would not get the reduction happening at that location. So the only correct answer for this one is the lithium aluminum hydride, followed up by water as the correct answer. Okay.